Well, in this video I want to take a look at the average value of a function and show an example. Now, the average value of a function is defined to be the over some interval to be the integral from a to b, initial x value to terminal x value over the interval of the function, and then divide that integral by the length of the interval. So 1 divided by b minus a be the length of the interval, if we say the interval is from a to b, and then integrate the function from a to b. And so in this particular example, we're going to look at this polynomial function here, and its average value over the interval from -2 to 3 is 1 divided by 3 minus the -2, integral from -2 to 3 of the function, integrating with respect to x, function of x. Well, this integral here evaluates to 425 divided by 12. 3 minus the -2 is 5, so the average value of this function is 1/5 the value of the integral, which is exactly 85 divided by 12, or about a little over 7.08. Now the geometry of that I'm going to take a look at here. The actual geometry, looking at Geometer Sketchpad, average value of a function. Now what I've got pictured in blue is the graph of the function, and here is -2 on the x-axis, and here is 3. So the average value of this function over the interval from -2 to 3 is what was just computed in the video. And I've highlighted a point up here, E, which is approximately at a point on the graph where the functional value, the y value, is the average value of the function. I'm actually at the point where the y value is 7.07, average value of the function, which is a little over 7.08. So in this case, the integral evaluated relative to the picture on the screen in square centimeters, 135.2. And then you can see this rectangle picture here where the one dimension is the length of the interval, 5, and the other one is the y value at this point, E, about 7.07, which gave us a rectangle with side AC and side AB, and the product, the area of the rectangle, 135.31 square centimeters on the screen. Area is about 135.2 square centimeters, so it's pretty close. I wasn't able to get it any closer than this in my picture, but gives you an idea of the size of the rectangle, whose area will equal the integral from -2 to 3. You can also observe in this case that you got two other points. It looks like a point over here and a point over there, where over this -2 to 3 interval, the average value of the function could be found on the graph of the function. Like if I move point E, I grab it here and move it over here, and we can see as I go up a little passage, go down close to 7.08. The area of the rectangle is close to the what the integral was. And if I went back over on the other side, there's another point over here where the function value is about 7.08. Can't seem to get very close to it here this time with my old hands. But I'll try and get a little bit closer here. Yeah, it's pretty good, 7.09. So here the area of the rectangle, 135.64 square centimeters, pretty close to the 135.2 square centimeters, which is about the area of the under the graph of this blue function from -2 to 3. Which if we had the exact average value of the function, if I could get the point E exactly on it, then we get an exact equality between the area of the rectangle and the integral, which would represent the area under this curve, the function from -2 to 3. Well, there you go. Average value of a function. Stay safe.